So, good afternoon. Am I audible?
Yes, sir.
Okay.
Yes, sir.
Okay, fine. So, in the last class, we have discussed the concept of work movement and also the definition of couple. And today, we shall discuss a very important theorem called as the Varignons Theorem. Varignons Theorem, or it's also called as principle of moments. Principle of moments. So, this Varignons Theorem is mainly based on the principle of moments. So, we know the definition of moment. So, moment is nothing but the product of the magnitude of force and the perpendicular distance about which we are going to consider the moment or take the moment. So now this is a very important theorem, Varignons theorem. So this theorem states that the moment of the resultant, about any point is equal to the algebraic sum of moments of the individual forces about the same point. So the Varignons theorem statement is the moment of the resultant. You know what is a resultant? Resultant is nothing but the combined effect of the given force system. So that is resultant. So if you consider the moment of that resultant with respect to any point, in the plane, it will be equal to the algebraic sum of moment of the individual forces about the same point. So now you can see here, this is also known as principle of moment. So in the examination, straight and true principle of moments, it is nothing but Varignons theorem. So the question may be asked indirectly, whether they may ask it as straight and true Varignons theorem, or it can also be called as the principle of moments. So the theorem states that the algebraic sum of moment of the individual forces of a force system about a point is equal to the moment of their resultant about the same point. So or else you can make the statement like this: the moment of the resultant of a given force system about any point will be equal to the algebraic sum of the moment of the individual forces about the same point. Now, let R be the resultant of the forces P1 and P2 and B be the moment center. That means we have two forces P1 and P2 acting at a point, concurrent forces, and the R being the resultant of these two forces. And we are going to consider the moment of these two individual forces and also the resultant about a point B. So that is the moment center. So that means the point about which you are going to consider the moment of these individual forces as well as the resultant. So B be the moment center. So let D1, D2, let D1 and D2 be the moment arm, or it is also called as the lever arm, or it is also called as the perpendicular distance from the line of action of the force to the point about which the moment is taken. So let D1, D2 be the moment arm of the forces R, P and P1 respectively from the moment center B. Now, so we have to prove that the moment of the resultant, that is moment is nothing but R into D. D is nothing but the perpendicular distance, should be equal to the algebraic sum of moment of these two forces about the same point, that is P1 into D1 plus P2 into D2. So we have to prove this. That is R into D is equal to P1 D1 plus P2 D2. Now let us construct the figure. Now you have two forces P1 and P2. You can see these two are the forces P1 and P2 acting at a point, and the diagonal represents the resultant. So we can complete this parallelogram. So already we have discussed this concept in the law of parallelogram of forces, how to find the combined effect of the resultant. Now here we have two forces in magnitude and direction, that is P1 and P2, and R be the resultant of these two forces. Now, suppose if we consider a point, that is say P, so this point is the moment center about which you are going to consider the moment of the resultant as well as the moment of these two individual forces. Now let small d, D1 and D2 be the perpendicular distance from the line of action of the force to the point about which you are going to consider the moment. Now let us reconstruct this figure. Now here we have two forces P1 and P2 acting at a point, and R be the resultant, and these are the corresponding distances D, D1 and D2 respectively. Now, so let us draw a line AB, correct? You join the point AB. So let us draw the join these 2 points. So let us call this point as A and join point B by a straight line. So let us consider this line AB as our vertical axis or the y-axis, and obviously perpendicular to this will be our x-axis. This will be our x-axis. So now the resultant makes an angle theta with respect to x-axis, as well as it also makes an angle, same angle theta with respect to vertical axis. So the resultant makes an angle theta with respect to both vertical and horizontal axis. What we have done is we have considered 2 forces acting at a point, and R be the resultant, and D1 and D2 are the perpendicular distance. And this point is nothing but the point about which you are going to consider the moment of resultant as well as these 2 individual forces. Now join line AB. So we shall consider this line as y-axis and perpendicular to this is x-axis, and resultant makes an angle theta with respect to x-axis as well as y-axis. Now we have to prove that R into D should be equal to P1 into D1 plus P2 into D2. That means the statement is the moment of the resultant about any point is nothing but the algebraic sum of moment of the individual forces about the same point. So in our case, the moment center is point B. Now join AB and consider it as the y-axis and draw the x-axis at right angle to it at A. So let theta be the angle made by the resultant with respect to x-axis, and note that the same angle is formed with respect to y-axis by the perpendicular to R from point B, from B. And note that this point is called as B1. So we can call it as B1, or we can keep it as B. It's okay. Now we know that R into D, that is the moment of the resultant about point B. The moment of the resultant about point B, R into D, is equal to R into, so this D is nothing but, this is the perpendicular distance. This is the perpendicular distance. Now if you consider this triangle, so you call it as point B1, this is B1 and this is B. Now if you consider the triangle ABB1, so this side BB1 is nothing but your D. So this is nothing but, it is AB cos theta, correct? AB cos theta. So if you consider this triangle, so this is the adjacent side and this is the opposite side, and this being the hypotenuse. Obviously D can be replaced as AB cos theta. So R into D is equal to R into, so D is nothing but AB cos theta, or you can rewrite this equation as AB into R cos theta. AB into R cos theta. So this R cos theta is nothing but the x component of the resultant. X component of the resultant. So hence you can call it as R suffix x, Rx. So this Rx is nothing but it is the x component of the resultant. So hence I can rewrite this equation as R into D is equal to AB into Rx. So this Rx is nothing but the horizontal component of the resultant. So where Rx is the corresponding, Rx is the component of R in the x direction. Similarly, if P1x and P2x are the components of the P1 and P2 in the x direction respectively. So if you consider these 2 forces, obviously P1 and P2 will be the horizontal components of these 2 individual forces along the x direction. Now I can say it as P1 D1. P1 D1 is nothing but AB into P1x, and P2 D2. P2 D2 is nothing but AB into P2x. So same thing here, AB into Rx. So here R into D is nothing but AB into Rx. Hence P1 D1 is equal to AB into P1x, and P2 D2 is equal to AB into P2x. Now adding the equations 1 and 2. So adding the equations 1 and 3. So here both these equations. So now P1 D1 plus P2 D2, you can write it as AB into P1x plus P2x. So if you add it, so P1 D1 plus P2 D2 is equal to AB into P1x plus P2x. Or P1 D1 plus P2 D2 is equal to AB into Rx. So which is nothing but the resultant. Rx is nothing but the resultant. So hence Rx is nothing but P1 D1 plus P1x plus P2x. Hence R into D is nothing but P1 D1 plus P2 D2 into AB into Rx. So this is the equation. Now, so since the sum of the x components of the individual forces is equal to the x component of the resultant R, so from the equation 1 and 4, we can conclude that the moment of the resultant about any point will be equal to the algebraic sum of the individual forces about the same point. So is it clear? I hope the concept is clear. Anyone has doubts on this concept? You can ask freely, no hesitation. So shall I move on to the next concept? I hope the concept is clear. So I should get some answer here, either yes or no.
Yes, sir.
I think it's very simple, nothing great about this concept. It's very simple. So basically, the Varignons theorem is also called as the principle of moments. Now, so far we have discussed all these concepts. Now we know that what is a couple and what are the properties of couple, and we also know the types of couple, whether the couple can be clockwise couple or anti-clockwise couple. So this completes the fundamental concepts in engineering mechanics. So these are the exercises problems. That means we know, define the following terms. We know what is statics, we know what is dynamics, and what are the two divisions of dynamics. We know that is kinetics and kinematics. And what are the four characteristics of a force? We know the characteristics of a force. That means a force can be identified in a given force system by its magnitude, by its line of action, by its point of application, by its sense, and by its direction. And we know what are the three types of force system. That is a collinear force system, coplanar concurrent force system, coplanar non-concurrent force system. And we also define the principle of superposition of forces and also the principle of physical independence of forces. And what are the various methods of finding the resultant of a system of coplanar concurrent forces. There are basically three methods. One is law of parallelogram of forces, and the second one is law of triangle of forces, and the third one is polygon law. So in your syllabus you have only the law of parallelogram of forces. Then we also discuss the definition of moment, how you can calculate the magnitude of a moment, and also define Varignons theorem of moments. So just now we have discussed what is Varignons theorem and the definition of a couple and what are the two types of couples. So next we shall move on to the numerical problems. Numerical problems where we will be using all the concepts, that is the concept of resolution of a force, the concept of composition of a force, and how to find the moment of a given force system with respect to any point, and also how to find the magnitude and direction of a given coplanar concurrent force system. And we have already discussed what are the different system of forces. That is, we have coplanar concurrent forces, and also we have coplanar non-concurrent forces, and also collinear forces. Next is the coplanar concurrent force system. So coplanar concurrent force system is if two or more forces are acting in a single plane and passing through a single point, such a force system is known as coplanar concurrent force system. So already we have discussed that means in a given concurrent force system on a xy plane, if all the forces are concentrating at a point or it is originating at a point, and such a system of forces is called as coplanar concurrent forces. Suppose if we have been given with a coplanar concurrent force system, then you need to find the magnitude and direction of a given coplanar concurrent force system. Now we have to follow certain step-by-step method in order to calculate the magnitude and direction of a given coplanar concurrent force system. So in a coplanar concurrent force system, we can calculate the magnitude as well as the direction of the resultant. The position, however, cannot be determined because of all the forces are meeting at a common point. So here in case of coplanar concurrent force system, you need not have to calculate the moment because you don't have the perpendicular distance in case of the coplanar concurrent force system to calculate the moment because all the forces are acting at a point. Whereas in the case of non-concurrent force system, along with magnitude and direction of the resultant, you need to calculate the position of the resultant. The position of the resultant is nothing but it is the moment of all the forces with respect to any given point. So the word position means you have some distance with respect to the line of action of the force and the point about which we are going to consider at the moment. So there will be using the concept of the principles of moments or Varignons theorem. So now there are certain steps to be followed in order to find the magnitude and direction of a given coplanar concurrent force system. So first is we should select a reference axis about which we are going to find the magnitude as well as direction of a given coplanar concurrent force system. So the equations for finding out the magnitude and direction of a coplanar concurrent system is, that is the magnitude of the resultant. We need to find the magnitude of the resultant. So it is nothing but square root of sigma f of x square plus sigma f of y square. And the direction of the resultant you can calculate by using this expression. Theta is equal to tan inverse sigma f of y by sigma f of x. So only you need to calculate the magnitude and direction of a given coplanar concurrent force system. So now here the step to solve problems in the coplanar concurrent force system, therefore, as follows. First, calculate the algebraic sum of forces acting in the x direction. So we can call it as sigma f of x. That means algebraic sum of all the forces acting in the x direction, and also all the algebraic sum of all the forces in y direction. So you can call it as sigma f of x and sigma f of y. So in some of the textbook they use the notation sigma horizontal forces sigma h, and some of the vertical forces they use the notation as sigma v. So both are same. Sigma f of x, we can use it as sigma f of x for algebraic sum of the horizontal components, or else you can use it as sigma h, and for the algebraic sum of vertical components you may use it as sigma f of y or sigma v. So once you find the algebraic sum of the components along the x and y direction, then directly you can find out the magnitude of the resultant by using the expression r is equal to square root of sigma f of x square plus sigma f of y square. So once you find the magnitude of the resultant, you can find the direction of the resultant by using this formula, that is theta is tan inverse sigma f of y by sigma f of x. So these are some of the steps you need to follow in order to find the magnitude and direction of a given coplanar concurrent force system. So next we shall solve some of the problems on concurrent force system. We shall start from a very simple problem. So now here you have an xy plane and you have a force of magnitude 200 Newton, so which makes an angle 40 degree with respect to the horizontal axis. Now we have to find the magnitude and direction of the resultant. So since here you have only a single force, we need to find its x component and y component, its y component and x component. So now we will be using the concept of resolution of a force. Resolution of a force, wherein we are going to divide the force into two components, or one along the x direction and one along the y direction. Now if I draw a line here, imaginary line, so you can construct these two triangles. You draw a dotted line here. So this is one triangle, correct? Now you can see here, this force is acting in the first quadrant. You can see the sense of the force. It is acting in the first quadrant, and the direction of this force is 40 degree with respect to the horizontal axis. Now if I resolve this force with respect to x axis, so since the components of these force in first quadrant, both f of x is positive and f of y is also positive. Now if I resolve this force with respect to horizontal axis, its x component will be 200 cos 40, correct? 200 cos 40. So if you consider this triangle, so this will be the opposite side and this will be the adjacent side, and this being the hypotenuse. So cos theta is nothing but the adjacent by hypotenuse. So the x component of this force is, you can see, is f of x is f cos theta and f of y is f sin theta. So here in our case, we know the magnitude of f, that is 200 into cos 40 is equal to 153.208 Newton. Suppose if you want to resolve this force along the vertical direction, so if this is 40, obviously this angle is 50, correct? This angle is 50. Then this triangle you have to consider. This triangle you have to consider. Here, this becomes the opposite side, and this becomes the adjacent side, and this is hypotenuse. Suppose if you resolve this force with respect to y-axis, its x component will be 200 sine 50, because opposite by hypotenuse is sine theta. So 200 sine 50, if you resolve with respect to x-axis, it is 200 cos 40. Both are same. Both will give the same answer. Either you can resolve with respect to x-axis or with respect to y-axis. So when we move further in subsequent problems, you have the angles of the given force V either with respect to x-axis or y-axis. Now, to begin with, we have only a single force. Now its x component is F cos theta, or it can be F sin theta. If you consider this triangle, it is F sin theta. So similarly, its vertical component is F sin theta. So now, if you divide this force, the components F of x and F of y, both the arrows finally should meet at this point. Now, if I components along the y direction, F of y is F sin theta, that is 200 into sin 40, that works out to be 128.557 Newton. Now, if you want to get back this original force, F is nothing but square root of F of x square plus F of y square. So here we have used the concept of resolution of a force in order to find the x and y components of the given force. So now, next we shall move on to the next problem. Now you can see here, we have nearly 5 forces acting at a point. So this one being 100 Newton, which makes an angle 45 degrees to x-axis, and again we have a 200 Newton force. Here you can see it is making an angle 30 degree with respect to vertical axis, and here again you have a 200 Newton force. It is making an angle 30 degree with respect to y-axis, and again you have a force of 275 Newton, which makes an angle 6 degree with respect to x-axis. Again you have one more force, that is 250 Newton, which makes an angle 20 degree with respect to vertical axis. Now here it is a concurrent force system where you have more than a single force. In the earlier problem we had only one force, so there we have calculated its x and y component. Now here you have nearly 5 forces, so we need to find the sigma f of x and sigma f of y. Now in any case you have to first select the reference axis about which we are going to find the algebraic sum of x and y components. So I have selected the x and y component. So this quadrant being first quadrant, so this is second quadrant, and this is third quadrant, and this is fourth quadrant. So one by one we shall deal. So now this force, 100 Newton force, so sigma f of x, either it can be 100 cos 45, or it is 100 sin 45. If I complete this triangle, you can either with respect to y-axis or x-axis. Now here, since the angle has been given with respect to x-axis, either it can be 100 cos 45 or it can be 100 sin 45. So both the angles are 45. It makes an angle 45 degree with respect to x-axis as well as y-axis. Now let us move on to the, now you can see here it is 100 cos 45. Now next force 200. Now this makes an angle 30 degree with respect to y-axis. Obviously it makes an angle 60 degree with respect to x-axis. Now let me resolve this force with respect to y-axis. If I resolve this force with respect to y-axis, its x component being 200 sin 30. You can see here it is 200 sin 30, or it can be 200 cos 60. Both are same. You can either resolve with respect to x-axis or y-axis. If I consider with respect to y-axis, its x component is 200 sin 30, or it can be 200 cos 60. So next is this one, 200 Newton force, which again makes an angle 30 degree with respect to y-axis. Obviously this angle is how much? 60. So either I can resolve with respect to x-axis. Now the x component of this force in the second quadrant is negative. So either it will be minus 200 sin 30 or it is minus 200 cos 60. So you can see here it is minus 200 sin 30 or it can be minus 200 cos 60. So we have resolved this one, we have resolved this one, and we have resolved this one, horizontal component, that is 200 sin 30 or it is 200 cos 60. Now this force, 275 Newton force, so it makes an angle 6 degree with respect to horizontal. Its x component is minus 275 cos 6. You can see here, minus 275 cos 6 degree. Now we have been left with only this one. So it is 250 Newton. It makes an angle 20 degree with respect to y-axis. So its x component is either 250 minus 250 sine 20, or it can be the remaining angle is how much with respect to x-axis? It is 70 degree. That is 250 minus 250 cos 70. Either it can be minus 250 sine 20, or it can be minus 250 cos 70. So here he has taken minus 250 sine 20. So now we have resolved all the fours one by one. That is 100 cos 45, 200 sine 30, minus 200 sine 30, minus 200, 275 cos 6 degree, minus 250 sine 20. So these are the values. So sigma f of x works out to be minus 288.28 Newton. So either you can write this minus, or in the bracket, the sum of the horizontal component is towards negative axis, or else in the bracket you can show the arrow. The arrow is towards negative direction in the bracket. Either you can use a minus sign, or in the bracket you can show the arrow, which implies that the sum of x component is in the negative direction. Now similarly, let us find the sum of y components. So again, here plus 100 sine 45, plus 100 sine 45, you can see here, plus 100 sine 45. Now if I take up this one, it is plus 200 cos 30. It is plus 200 cos 30. Now you can see here, it is plus 200 cos 30, or it can be, if you consider with respect to x-axis, it is 200 sine 60, 200 sine 60, because this angle is 30, obviously this is 60. So if I consider this force with respect to y-axis, x-axis, its vertical component is either 200 sine 60 or 200 cos 30, 200 cos 30. Now this force, so in the second quadrant, sigma f of x is negative, f of y is positive. F of y is positive. So if I resolve this force, already it is minus 200 sine 30. Its vertical component will be plus 200 cos 30. You can see here, plus 200 cos 30. 200. So I request all of you to mark your attendance in the chat box, because the time is over. So please mark your attendance in the chat box. So next class we shall continue. Tomorrow you have my class at 11:40. We shall solve some more problems.
Hi, sir. Come now.
This, you people are following the concept? Hello?
Yes, sir.
No issues with the presentation, I hope. So please mark your attendance. So I'll be ending the session. So thank you so much. So have a nice day. Stay safe. So thank you. So we shall meet tomorrow morning, 11:40. Till then, have a nice day. Goodbye. Thank you.